All right, guys, are there any questions over any of the assignments so far? Now, what we're looking at today is solving these rational equations. We did this some yesterday. We're going to do a few more of them today, and starting to look at rational equations that have an extraneous solution. An extraneous solution is just a solution that we get from solving it that doesn't work in the original equation. And one of the main things, or main ways that we'll get extraneous solutions from rational equations is it's going to be a value that would make the denominator be 0. And if we look at this first one here, x plus 1 and 2x, those are the main places where we could have a denominator of 0. And just so, to see what our extraneous solutions would be setting them equal to 0 and then solving to see what values of x would make it be 0. Well, with x plus 1, we can subtract 1 from both sides, telling us that if x is negative 1, we would have a denominator of 0, so x cannot be negative 1. Here we can divide by 2, telling us x is 0, so x cannot be 0. So if we get negative 1 or 0 as a solution, it would be considered an extraneous solution, and we can eliminate it. Now, if we look at this here, what do we need to multiply everything by to get the denominator simplified? Yes. X plus 1 and 2x. Because for our first one, the x plus 1 and x plus 1 would cancel. For the middle one, we'd have the 2x and 2x. And for our last one, the 2x and 2x. Because 2x in each of the denominators only appeared once, we only need it once. Now what that leaves us with is 3x times 2x minus 5 times x plus 1 is equal to 3 times x plus 1. Now at this point here, we can do some simplifying, multiplying together. So we'll do 3x times 2x. Well, 3 times 2 is 6, and x times x is x squared. Now we can distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. Is equal to, here we can distribute the 3. 3 times x is 3x. And 3 times 1 is going to be plus 3. Any questions on this here so far? Now at this point here, we can combine like terms. Well, we would if there were any. So we need to get everything on the same side of the equal sign. We can subtract 3x from both sides. So we have 6x squared minus 8x minus 5 is equal to 3. And then we would subtract 3 from both sides, which should tell us that we have 6x squared minus 8x minus 8 is equal to 0. Because again, we're trying to get it equal to 0 so that we can solve from there. Is there a greatest common factor between these three? 2. We can divide it out. Because if there's a greatest common factor that is a number, it's going to be easier to go on and divide it out, so it's a little bit easier to work with. Because when we divide it out, we have 3x squared minus 4x minus 4 is equal to 0. Because that's going to be a little bit easier to solve than 6x squared minus 8x minus 8. So we can factor this here. Since the 4 is negative, it is indeed, the signs are going to be opposite, plus and minus. Factors of 3x squared, well, we'll have x and x for our x squared. And factors of 3 are 3 and 1, so we can put a 3 in front of one of the x's. Now the factors of 4 are 1 and 4 or 2 and 2. 2 and 2. Now we can check it just to make sure we did get the correct middle term. 3x times negative 2 is negative 6x. 2 times x would be plus 2x, which gives us a negative 4x, which is indeed the middle term we wanted. Now at this point here, we do have two things multiplied together to equal 0, so one of them must be 0. So we have that 3x plus 2 is equal to 0, and x minus 2 is 0. Well, 3x plus 2, the first thing we can do is subtract 2 from both sides, telling us that 3x is equal to negative 2. And we can divide both sides by 3, telling us x is negative 2/3. Now for our other one, we can add 2 to both sides, telling us x is equal to 2. And that's it. Now are either one of these one of our restrictions? No. Because for this one here, we said x could not be negative 1 or 0. It's neither one of these. So those are our two solutions. Questions on this here? Let's look at the next one here. Now this one here is a little bit different because if we look at the three denominators, one of the denominators is actually factorable. Because it would be very tempting to want to multiply each one of these expressions by x plus 1 and x squared minus 1. However, that would make it a little more challenging than it needs to be. Because if we factor all the terms down, we will see something interesting. Now the x plus 1 doesn't factor. There's no greatest common factor between x and 1, and its degree is 1, so it's as simplified as it gets. Now x squared minus 1, we have an x squared, so a degree of 2, so it's probably going to factor. And what would it actually factor to? X plus 1 and x minus 1 is our difference of perfect squares, one of the nice ones to factor. So we have this here. So it's going to help us to see what we need to multiply everything by. But it also tells us if I had multiplied the entire thing by x plus 1 times x squared minus 1, which really this is x plus 1 times x minus 1, we would actually have been multiplying the whole thing by x plus 1 twice, which means we added an extra factor of x plus 1, which means the solution for that would show up an extra time. But again, it's extraneous, so we'd have to take it back out. It doesn't help us. So yes, we would multiply everything by x minus 1. And in the middle, the x minus 1 and x minus 1 would cancel. Now the first one, we have x plus 1, so the x plus 1 and x minus 1 aren't the same, so they wouldn't cancel. So we also would need what? We also need to multiply everything by x plus 1. So in the middle, the x plus 1 and x plus 1 would cancel. The first one, x plus 1 and x plus 1 would cancel. So we do need one x minus 1, and we do need one x plus 1. We don't need 2. And that's what I was going to say with the x squared minus 1. It would give us an extra set of factors. Now before we continue on, if we want to look at our restrictions, because we would need to see when x plus 1 and x minus 1 would be 0. Exactly. So if x is 1 or negative 1, either one of those values would not work. Now at this point here, we can go on and start solving. So with this here, we'd have 4x plus 1 times x minus 1 is equal to 12. Because luckily, everything we multiplied it by, simplified out with its denominator. And the last one, we've got 3 times, well, wait a minute. We have both of these here, yes, the x plus 1 and x minus 1. Where did we get x plus 1 and x minus 1 from? It was the factors of x squared minus 1, yes? So I could put it back out, or I could just say x squared minus 1, yes? Because we could do, there's nothing wrong with saying x plus 1 times x minus 1 and putting it there. But if we distributed, x times x is x squared. Here we'd have minus x plus x minus 1, which is just x squared minus 1. If we factored and had 2 parentheses that we factored out show up as part of the steps, especially here that we're multiplying back together, might as well just go on and replace it with what we factored it from, because it's going to get back there anyways. Any questions on how we got to this point here? Now at this point we can do some distributing because unfortunately 4x plus 1 times x plus 1 didn't show up earlier, so we'll need to multiply this through. 4x times x is going to be 4x squared. 4x times negative 1 is negative 4x. 1 times x is plus x, and 1 times negative 1 is negative 1. Now I'll need to multiply through the 3 with the x squared minus 1. And if we do this here, 3 times x squared is going to be 3x squared. 3 times negative 1 is negative 3. Now at this point here, we do have some like terms on both sides. So the negative 4x plus x will be negative 3x minus 1. On the other side, we do have 3x squared. Now we do have over here the 12 minus 3, which would be plus 9. Now we do need to move everything from one side to the other. We need it equal to 0 because we have quadratics. Now the direction we move it's really going to be up to us, because we could move everything from the left side to the right or everything from the right side to the left. Now normally when I decide this, it's figuring out which one has the x squared, but this one they have both, and yes, I would agree. So since they both have x squared, I look at which one's bigger. 4x squared is bigger, yes? So we'll remove everything to the left. Because if I can keep the term with the biggest term with the variable with the biggest exponent positive, I'm going to do that. So here, I'm going to try to keep the x squared term positive. So we'd subtract 3x squared from both sides. 4x squared minus 3x squared is going to be x squared. Minus 3x minus 1 is equal to 9. Continuing with that, we would subtract 9 from both sides. So we have x squared minus 3x minus 10 is equal to 0. Questions on this here? Now at this point here, we can solve this by factoring, graphing, completing the square quadratic formula. We can solve it by any of them here. Now this one here, graphing might actually work out easier than factoring. And the reason I say that is because the first one we ended up having a fractional answer, yes? One of the ways that we know that most likely we're going to get a fractional answer is if a is different than 1. So if we have a value of a other than 1, there's a good chance we'll get a fraction, because we have to divide at the end. Since a is 1 for this here, x, we can type it into the graphing calculator, y equals, type it in and hit graph. And again, we're looking for where it crosses the x-axis. We're looking for what value of x is going to make the y be 0. We're going to go second table. Negative 2 and 5. And that's it. So over here we could say x is equal to negative 2, comma, 5. And those would be our answers. Now we can factor this, because if we factored, we'd have our 2 sets of parentheses equal to 0. Plus and minus. Factors of x squared are x and x. And as we know, well, the factors of 10 are 1 and 10 or 5 and 2. Well, the 5 would be on the negative, and 2 would be with the plus. Now that we have two things multiplied together equals 0, one of them must be 0. With the x plus 2, we would minus 2, telling us x is negative 2. And with the x minus 5, we would add 5, telling us x is equal to 5. So we get the exact same answers. And that's it there. And since, again, neither one of these is one of our restrictions, so both of the solutions work. And that's it for that there. Hopefully these here, solving these rational equations, is becoming easier and not as bad as y'all thought they were when we started. Are we ready for the last one of the day? Yes. All right. This one here is going to have extraneous solutions. There's kind of a few reasons I know this one as I put these note sheets together. And there's one other kind of piece of information that we have from this that kind of screams that it's going to have an extraneous solution. Do you all see it? Solving an equation with an extraneous solution, it kind of tells us it's going to happen. I leave those in there partially for my own sake to remind myself that it is going to show up. So this one here will definitely have an extraneous solution. It's going to have a number that doesn't work, but will come out as an answer. Now, before we look at those or those extraneous solutions, it is going to be helpful to have all the denominators factored completely so that we can see what values of x we cannot have. Now, the x minus 3 under the 6 and the x plus 3 under the 4x, those are as simplified as it gets. The one that we do need to factor is the x squared minus 9. Yes, it would be x plus 3 times x minus 3. It's our difference of perfect squares. And luckily for us, we're not going to get more than 2 factors. We might get 3 in some cases, and those aren't going to be too bad. But we're not going to have too many where the least common denominator, what we multiply through, or what our restrictions are going to be more than 2 or 3. So most likely, since we had x plus 3, x minus 3, the middle one's going to have both, or have 2 of 1. Does that make sense? It's not going to be that the middle one's going to be x plus 4, x minus 4, or we have 4 different ones to look at. Now, at college algebra, that might be something that they'd add. That's the only real difference between Algebra 2 and college algebra. They'll add a few more things in. So, with this here, we know that x minus 3 cannot be 0, and x plus 3 cannot be 0, because if either one of those is 0, we're dividing by 0, it doesn't work. So here to solve, we would add 3, telling us x cannot be 3. Exactly. And for the other one, we minus 3. We find out that x cannot be negative 3. So if we get a solution of 3 or negative 3, it would be an extraneous solution and does not work. Questions on this here? Now, I will point this back out once we finish solving this. Having these listed out is nice because what that means is that I don't have to continuously check, i.e. plug the numbers back into the equation to make sure that they work or don't work if we have them already listed. Now, with this here, one thing we know we'll need to multiply all 3 rational expressions by is x minus 3. Because in the first one, the x minus 3 and x minus 3 would cancel. In the middle, the x minus 3 and x minus 3 would cancel. In the last one, well, the x minus 3 won't cancel. But we'll also need an x plus 3. Now the first one, we don't have anything else that simplifies, but the middle, the x plus 3 and x plus 3 will cancel. And then the last one, x plus 3 and x plus 3 will cancel, leaving us with 6 times x plus 3 is equal to 8x squared times nothing, it's just 8x squared minus 4x times x minus 3. Now at this point here, we do need to distribute, so we do 6 times x, which is 6x. And 6 times 3 is going to be plus 18 is equal to 8x squared. Negative 4x times x is negative 4x squared. And negative 4x times negative 3 is going to be plus 12x. Now we can combine like terms. 8x squared minus 4x squared is going to be 4x squared plus 12x. Now we do need to move everything onto the same side of the equal sign, yes? Now for some, I leave this till later. I'm just going to go on and show you guys this here. One of the first things we could do here is what? Subtract 6x from both sides, yes? What do we need to do next after this? Subtract the 18, yes? There's nothing says that I have to do it as 2 separate steps. I could do it all at once. We do it as 2 separate steps so that, especially when y'all are getting used to this, keeping track of things one at a time. But I feel like at this point here, y'all are comfortable enough doing this step that you can do it together, which is really going to give us 0 is equal to 4x squared plus 6x minus 18. Is there a greatest common factor? 2. So we can divide 2 out of all the terms. Tells us 0 is equal to 2x squared plus 3x minus 9. Would graphing be a good method to solve this here? Because what's the value of a? Number in front of x squared? 2. So most likely we're going to get a fraction. Because if we factor it, or going through factoring steps, back up here, because the first one here, we had an a different than 1, which means here we ended up having to divide it back out, yes? So if we have a different than 1, most likely it means that we're going to have a fraction as one or both of our solutions. And graphing, unfortunately, doesn't work well with fractions unless we kind of know what fraction we're looking for. So here, might be better to go on and factor it. Now, since 9's negative, our signs are opposite, plus and minus. Factors of 2x squared, well, we'll have x and x. 2 and 1. I have a feeling I'll probably need to flip the signs. Now we look at the factors of 9. Factors of 9 are 1 and 9 or 3 and 3. 3 and 3. And I'll check this here to make sure. 2x times negative 3 is negative 6x. 3 times x is going to be plus 3x, which gives us a negative 3x. Is that the number we wanted? No. Correct number, but wrong sign. So we just need to fix the sign, change it from negative to plus, and change the other one from plus to negative. So we just need to switch the signs to give us 2x minus 3 and x plus 3. And if we checked it again, 2x times 3 is going to be 6x. Negative 3 times x is negative 3x, which just gives us a middle term of positive 3x, which we did want. Now, last but not least, we have 2 things multiplied together to equal 0. So one of them must be 0. Now, for the first one here, first thing we can do is add 3 to both sides, which tells us that 2x is equal to 3. Then we can divide both sides by 2. telling us that x is 3 over 2. And there's one of our solutions. For the other one, we would subtract 3 from both sides, telling us x is equal to -3. Exactly. It can't be -3 because -3 was one of our restrictions, so we throw that solution out. And that's why it's called an extraneous solution, because we do get it as a solution for our solving steps, but it doesn't work in the original context. Any questions on this here? And part of the reason, I think y'all get it. The extraneous solution is when we plug it back in, we would get a denominator of 0. So we'll stop there for today. And what we'll be doing tomorrow is just finishing up the note sheets, doing a few more of these here.